Hello everyone. So today I think I will start a new session about uh, graph transformation. I think this is a very important topic that I didn't like the way it was approached or presented in textbooks. So to tell you the truth, I stayed like 2 or 3 days doing nothing except thinking about how to make it easier. Is there a way? And I think I found a way that is much easier than, the bunch of if-then statements that they tell you. If there is, translation and reflection, you do this before that, and so on and so forth. So I thought I'm going to divide that into 3 videos so that it won't be too long, and and at the same time, because the groups I'm going to use are slightly different from one another. So I will start today with polynomial functions. Okay, let's see what a polynomial function is, and then what are the type of transformations that we have or we are going to deal with. There are mainly 4 types of transformations that usually we use, but I'm going to defer one of them, as most textbooks do for now, because it's more advanced, and this is rotation. I'm going to have a session in the future about rotation, but we are going to talk about translation, magnification, or like shrinking or stretching, and reflection over an axis, and pretty much the x or the y. Again, later I will have an advanced session on how to reflect over a straight line, an inclined line, or how to rotate by any angle other than 90 degrees. Okay, and then the third, so this is for polynomials. Next, I will do an equation about, say, the square root, a session about the square root, the exponentials, the absolute value, and finally I will finish with trig functions. So let's talk about polynomial functions first. So what is a polynomial function? Poly, of course, means many, right? And nomial, the monomial, the binomial, it's like how many terms. So these terms, so let me switch to the hover cam and then use picture in picture. Okay, so polynomial functions. A polynomial function is a function that it has terms that are all powers of x, but not any powers. These powers are positive integers. So I can write it as y equals ax to the n plus bx to the n minus 1 plus plus plus, and maybe depending on how many terms I end up with the letter, let's say, plus e. Now, we call n here the degree of the polynomial. We refer to the a, the b, all these constants as the coefficients. But one of them in particular, the a, the coefficient of the highest power, the coefficient of the degree, we refer to it as the leading coefficient because it is the leader, right? Leading coefficient. And again, for short, we are going to refer to it as LC. Now, any polynomial with the power of x anything other than 0, because if it's 0, then you get y equals e. Y equals e is a horizontal line, right? I don't need an equation for that. I know y equals e is a constant, it's horizontal. But if n is any power, 1, 2, 3, 10, 100, it doesn't matter, then the right end and the left end will definitely end up being going up to infinity, positive infinity, or down to negative infinity. And the left side also going either up to positive infinity or down to negative infinity. So how do I know the end behavior? The end behavior helped me figure out an easy way to plot the function. So let's talk about leading coefficient. Very easy and common sense. I mean, there's nothing hard here. If the leading coefficient is positive, then the right end, I'm going to use RE for right end and LE for left end. The right end will end up going up. Sure enough, I mean, if you say y equals x and x approaches infinity, then y approaches infinity. That common sense. And if I say y equals negative x, I get a line with a slope go -1, meaning as x increases, y decreases, and eventually when x goes to positive infinity, y would go to negative infinity. So there is really nothing hard about that. The second thing, we are going to look at the degree. Notice these are the only two things I gave them name. Yes, the n, the degree. If the degree of the graph is even, then the left end follows or is consistent with the right end. Meaning, if I have y equals x squared, I know x squared, meaning the leading coefficient is +1, then the right hand side is going up, and because 2 is even, then the left hand side also will be going up. And in reality, the function y equals x squared would look like that, like a v or a u, something like that. But if it's odd, and odd starts with o, then the left end would behave opposite to the right end. So x cubed, a is 1, right hand side is going up, left hand side will be going down, and the function would look something like that. Something also to know is the number of turns in a graph. Number of turns cannot exceed, so it's less than or equal to n minus 1, where n is the degree. You know that if I have a straight line, y equals x, n is 1. So the number of turns is 1 minus 1 or 0. Of course, there is no turns. It's a straight line. A straight line, straight, meaning it's devoid of curvature or turns. No turns. Y equals x squared, there is only a single turn. No more, and so on and so forth. So that's another thing you have to know. Now, let's look at some examples of polynomial functions. So, for example, I say, if I make b equals c equals d equals e equals 0, so I only have one term, a monomial, so to speak. But y, and the a is 1, y equals x to the n, we call these the parent functions of polynomials. Parent functions. So a parent function would be y equals x cubed, y equals x to the 5th, and so on and so forth. Why is that important? Because that would help us with transformations. For transformations, I told you we are going to look at three things. Number one, if the x or the y have addition to them, so I say x plus 4 or y minus 2, addition or subtraction, these results in what we call translation. So translations are either moving to the right or to the left, or up or down. So the graph, the whole graph, I can move it, shift it right or left if it affects the x, up or down if it affects the y. Okay? So that's translation. Number two, if I have multiplication or division, so instead of having, if a is not 1, so if it's 2x to the 4th, or 4y, or x over 2 quantity square, if it's multiplied or divided, we will end up with either stretching, or shrinking. So the x is either widens or narrows. Same thing, I stretch the y or I shrink it. Okay? So that's the second one. The third one is the change of sign. Change of sign meaning instead of a being positive, it becomes negative. Negative 2x to the n, or negative 5y. Okay? Or y divided by negative 2. Any change of sign. That results in what we call reflection. Reflection meaning, I wrote reflecting. Okay, reflection, it doesn't matter. So reflection meaning I either take the graph and turn it over the y-axis, assume that there is a mirror on the y-axis and I have a graph here or there. What is its image, so to speak? Or I have a mirror on the x-axis and how the image would be reflected, hence the term reflection over the x or the y. So let's take an example and see how that works. So I'm going, what do I mean by how we define or how we find what happened to my graph and and explain that. Okay, so let's take an example. Let's say y equals negative 8 times 3x minus 4 cubed. Well, cube will give me a hard time, but it doesn't matter. Minus 5. And I tell you, here is a function. Tell me what is the parent function and what happened to the parent function to become that. So meaning, how do I, if I know how to plot the parent function, how do I plot this function? Okay, so let's find the parent function. The parent function is found by deleting all the numbers in the problem, except of course the power, because that belongs to the polynomial, right? We are dealing with polynomials, something to the power of 2 or 3 or 4. So without the 3, if I take away the negative 8 and the 3 and the negative 4 and the negative 5, I end up with y equals x cubed. We call that the parent function. And the parent function is easy to find. If I know the x, I can find the y. So if this is negative 3, I get negative 27. If this is negative 2, I get negative 8, negative 1, negative 1, 0, 0, 1, 1, 2, 8, 3, 27, 4, 64, 5, 125, and so on and so forth. Cube, just cube. Now, let's forget this for a second. And to begin with, I'm going to place them between parentheses, and because for a starter, you don't need to do that, but because I want to say on the right hand side I have a parenthesis that contains x. Oh, like this one. Okay, they look in a way similar, right? So I don't want to have anything other than that on the right hand side. So I have to get rid of the negative 5 by adding 5 to both sides, correct? That's what you learn in algebra. Then you will get y plus 5 equals negative 8 times 3x minus 4 cubed. I still have a negative 8, so why not divide both sides by negative 8? And when I do that, I want to write this also as the y between parentheses. And I'm going to leave the negative out. Why? Because you see, change of sign. So I'm going to write negative y plus 5 over 8 equals 3x minus 4 cubed. Very nice. Now, I need the right hand side, the quantity between parentheses, which is 3x minus 4, to look like that, which is just x. So if that was a mathematical equation. 3x minus 4 equals a constant, and you are solving for x. How would you find x? Definitely, as I know you know, I will start by adding 4, right? And then dividing by 3. Adding 4 to the x-axis, meaning let's move 4 units to the right. So I'm going to take the graph of x cubed, by the way, that looks something like that. This is the graph of x cubed. I'm going to take it and move it 4 units to the right. And then divide by 3. Of course, dividing by 3 meaning shrinking x by a factor of 3. I already explained all the transformations in x. When I go to the y and I want to find y, oops, I have a negative sign out. A negative sign, change of sign, means reflection. But reflection over what? If I have the y, it means I'm reflecting over the x. Think about it. If I have y equals 4, so any point x equals anything with y equals 4 here, and you change the sign of y, it means you are going down here from positive 4 to negative 4. So you are reflecting on the x-axis. And likewise, if x is negative and you change its sign, you mean you reflected it over the y. So x reflects on y, y reflects on x. So here I'm going to say reflect over x-axis. But in reality, I'm changing the sign of y, right? Change the sign of y. Then I'm going to multiply by 8. Multiplying by 8 means stretching y by a factor of 8. And then finally I get y plus 5, so I subtract 5, meaning move 5 units down. These are the 5 things I will do. And that's basically it. So now if I want to plot this, I can come back here. This would be a little tricky because the numbers will be probably fractional, most of them. Let's see what we did to the x. We added 4 and then we divided by 3. So if I add 4 to the negative 3, it becomes positive 1. Divided by 3, it would be 1/3. Add 4 divide by 3, you get 2/3. Add 4 divide by 3, you get 1. Add 4, 4/3. Add 4, 5/3. Add 4 divide by 3, you get 2. You get 7/3. You get 8/3. And you will get 3 for 5. That's how easy you find the x's. For the y, we change the sign of y. So negative 27 becomes positive 27. Then you're going to multiply it by 8. See why I said it's horrible? You get 216. And then you subtract 5, so you get 211 if I did the math correctly. The negative 8 becomes 8. Multiplied by 8, 64. Subtract 5, 59. Reflect 1. Stretch by 8, 8. Subtract 5, 3. Reflect stays 0. Multiply by 8, 0. Subtract 5, negative 5. Multiply by, reflect, it's negative 1. Multiply by 8, negative 8. Subtract 5, negative 13. Reflect negative 8 times 8, negative 64. Subtract negative 69. Reflect negative 27. We said it's negative 216, negative 221. Reflect negative 64. Multiply by 8, negative 512. Subtract 5, negative 517. Of course, these are, very large numbers, but let's see if that's really what happened. So if I go to plot this graph, x cubed, and then I go down and say negative 8 times 3x minus 4 cubed minus 5. Of course, the window here, the lowest x is negative 3. So let's make that negative 5. The highest is 4, so make it 5. The y minimum is negative 27, so maybe negative 30. The max, oops, it's negative 517. And the highest is 211, so make it 220 or something. I know this will not look nice, but at least here is the x cube function, and then it's showing you the other one. If you want to check the numbers, you can go to table, for example. You can go to second table, and of course I'm not going to check y1, so 2 is 8, 3 is 27, and so on. I know those. I want the others. So if x is 1, I get y2 is 3. You see? 1, 3. 2, negative 69. 3, oops. I didn't do 3. But we did, for example, you can do second calculate and find the value, and let's say x is 4/3, 4 over 3. Okay, it asks you, are you talking about the first graph? No, I'm talking about the second. So oops, no, I think I should have done that. Let's see, second calc value, let's say 1/3. It tells you x cubed. If you say enter, no, not enter. I usually don't use that. I'm sorry, I should have checked it first. So it tells you this is why this is y1, which we didn't do, which is 1 over 27. I think. Oh yeah, here is y2. So the bottom arrow, you get 211. And you can see that you can check. We know it's correct if you did the math correctly, but now you see how easy I explain the transformation. There is no reason to say, well, if I have multiplication and an addition, I have to do this before that without explaining. Now, if you look at this simple method, all what I need is to have only x between the parentheses and only y, and use very simple algebraic operations. One quick thing before I leave, I know it's a little long, but some people can see something interesting. Do you see that this 8 outside the parentheses can go inside as a 2, because 2 cubed is 8? This is a little more advanced. Some of you will get it. I could have rewritten this as y equals negative 6x minus 8 cubed minus 5. And this, unfortunately, you cannot use it in a test because they will tell you, where did you get this from? But it's really, if you understand what we did, you have many ways of describing what happened to the graph. Because now I'm going to say negative y, first of all, y plus 5 equals negative that, and then you say negative y plus 5 equals 6x minus 8 cubed. So now what I'm doing to the x, I'm adding 8, and then I'm dividing by 6, shrinking by a factor of 6, rather than to add 4 and shrink by 3. So, for example, let's pick one that would give us a nice number. If I take the 4, I add 8, it becomes 12, divide by 6, I get 2. Now, in the y, I only need to change the sign and subtract 5, right? Because negative will change the sign, subtract 5. So let's see what happens to the 2. So I say here, if I add 8 and then divide by 6, and we took the 4, right? I added 8, it becomes 12, divide by 6, I got the 2. Now, if I take the 64, change its sign, it will become negative 64, then subtract 5, I get negative 69. So you see, you get the same exact graph, and now it gives you a way to look at how many transformations will lead to the same graph. If you didn't get this part because I did it really quickly, don't worry, you can watch it. If it doesn't make sense, don't worry about it. It would be more advanced than what you are doing currently. But the most important thing is to learn. I try to include all 3 transformations in this example. Next time when we meet, I'm going to deal with more graphs, as I said, and then we'll finish with the trig functions. Thank you very much for your time. Sorry for being a long video, and hope to see you soon. Bye.